Here's a video of my Wissner CNC machine, and some people has asked me to show some more details in a video. So here's the video about the machine. It's a Wissner machine that's built by the company of that name in 1990. So it's a 24 years old machine. I'm told from the previous owner that it has a big enclosure going from from the factory it was installed at, with all the electronics, but at some time it burned, and then they didn't reuse the machine, and he got the machine and added some cheap electronics that I don't like. So he had it for some time but never got it to work perfectly, and there's a lot of issues. One issue is that the limit switches is resetting Mark III all the time because there's some interference or something that's getting the switches triggered even the machine is still and not running at all. So here's a video, and I will try to go into all the details about the machine. If you have any questions about it or like me to do more videos, please let me know, and I can maybe add some more videos with the extra details if there's something I'm missing. This stand slash car, it's the blue one it's standing on, is a pallet car that I have converted into be a stand for this CNC machine because this was the perfect size, as you can see. So at the moment I'm building this enclosure below, so it will have cabinet sizes all around. And here's the sides that will be cut into the parts and placed in here and in front of here. And on this side there will be some doors that can be opened. And inside this enclosure, all the electronics, the CNC, the computer, and all the bits and parts that for the machine will be in the closed enclosure below the machine. At the moment there's only the computer and a cable mess, as you can see here. I'm guessing the machine weighs around 300 kilo, and it's a pretty big job to lift the machine, and this is why I've used this rocket car. It's the machine has 3 feet, as you can see in here. There's one of the feet and there's 2 on the back. So I've built a holder that sit in the car where the feet will fit into perfectly. So as you can see, in the front there's 1 and on the back side there's 2. So it's easy to adjust the machine so it's level. As you can see, the size here, it's fairly big. so it's 9 centimeters. So it's 9 by 15 centimeters, and you can hear the steel. The table is also well built and is 2.5 centimeters. Sorry, I have to adjust the camera. 2.5 centimeters in thickness, so it's fairly good table. And as you can see, even that it has been in use for 24 years, it's, from what I can see, perfectly leveled. The table size is 80 centimeters by 60 centimeters. It's just a bit small, more than the 60 centimeters. Actually, it's 64.5 centimeters. Times 81, but the cutting area is 80 centimeters times 60 centimeters. I'm planning to use this machine to cut plastic, wood, aluminium, brass, copper, maybe some iron things. I don't know if the machine can handle steel, but maybe if it's running very slowly, it can cut some steel. So you can see here, this is the dust cover that's protecting the lower part of the machine from getting all the parts, the cutting waste into the machine. And it's using a nice Velcro system, so you can just unconnect it here. Here you can see the mount. See, the mount has the feet in, so it will hold the machine in place and it will never fall off the stand. And you can now see the size of this beam. 9 centimeters times 15. Not in this part, but in this part where it's wide. Here's the rails with 20 millimeters in thickness. And down here So you can see there's the limit switch. You can hear mark 3 saying the switch has been hit. So I've just added this extra beam down here so I could place the holder for the feet. And the spindle is placed inside here. I don't know if you can see it. You can see it here in the top corner there. In the other end of the machine we can see the spindle. I'll turn the machine on in a moment so you can see the machine. I'll just go over the machine first so you can see it. It's a bit hard to see the underside, but in there you can see the spindle with the connection block. There's the connection block mounted on the underside of the table. And up there on the right you can see one of the bearings, there's linear bearings that's gone on the rail. And there's the center block that's holding the spindle nut. Here you can see the rail. It's a nice massive one. It's 20 millimeters times 70 millimeters in size. There's only one rail. The X spindle is in a bit unusual way mounted, fixed, and is not turning. So inside the center housing here, in this housing, there's a stepper motor, and there's a belt drive, and there's a nut that's turning on the spindle and moving the car back and forth. But the spindle itself is mounted fixed to the machine and is not turning. Here's a limit switch. I'm planning to, all the electronics everywhere will be redone and checked up. The dust cover is sliding back and forth the machine and working nicely, and then at the ends here it's connected with Velcro, so it just holds on, no issues. This big cable chain was when I got the machine hanging, was not supported by this bracket arm. It's one I have added to the machine. So this cable chain was hanging low and was hitting the top of the cover when the machine was moving back and forth. And if I hadn't fixed it, it will have damaged the dust cover in a short while. So I've added the arm. I will show you the arm that's mounted and how it's mounted on the other side of the machine. So the machine is built in a way that I have not seen other machines done, with this arm coming out and then this coming up. So there's a nice big space there, so if we have something big, it can get past the holding arm for the x-axis. But the spindle cannot move to the x cannot move to more than here, and that's fitting with the spindle going to here, the center of the spindle. So I think it's a well designed machine. The only thing is the height here from here to here is 8 centimeters. So if the spindle is fully up, the full size the machine can cut is 8 centimeters. And I would like to at some day change that so it can be working on bigger pieces. The idea I have at the moment is maybe not the finish idea, but is to cut the machine, all this center part, I will cut this off, and here on the top add a new bar. So if you see here, so cut the machine here and here, and take all this away, and on top here and there add a new beam up here, and then move the x-axis up. By doing this I will maybe get 10-15 centimeters more room on the table to cut in travel. You can see the back side of the machine. It's a bit shorter. The arms, you can see here, it's a bit longer on the front size, and on the back size is not the same length. So it's a bit shorter on this end. So it's maybe 1/3 of the machine, and 2/3 of the machine is in front. Here we have the same cover system, and here you can see the spindle. This spindle is turning, and this is the fixed mount with the bearings that's holding the spindle from moving in this direction. And then in here there's a coupling. This is a push together coupling. So this motor, if you remove the 4 screws, you can just take the motor out, and you don't have to release any screws inside the coupling. So this part inside has the coupling, and the cable is coming here. This is maybe a thing I will change in later on, because it's for me annoying that the stepper motor is going so much out of the back end of the machine. It's around 8 centimeters, 9 centimeters or something. This is why this is added to protect the machine, so when I move it around, if it hits something, then it will hit that one. So the thing is that the center knob in here, it's a bit hard to see, but in there is in the center of the disc of the table. So my plan is maybe to move this motor inside and then have a bracket holding the motor, because the table will never come. The center knob is stopping around here. You can see it on the grease, that is not going to more than here, because at the center of the table, and when the table is at this point, the center is here. So there's place for the motor to be mounted inside, and then there will be a clean backside with no more stepper motor going outside. But I will not do that at the moment. I will get all the electronics and things to work, and then maybe later fix that issue. Here's another switch in this area. And again, here is just a part of Velcro. This is my grounding wire that I have connected. So there's one for the car below, and there's one for the machine, and this is going off to the control box that's down here. Take a moment. In a moment we will look at the control box. So you can see there's this dust cover plastic that's wrapped is connected with Velcro here, and on top of this there's this steel plates, so you can move it back and forth this way and have a nicely closed surface, so it's easy to clean and remove cutting materials from the machine. Here's the marking plate on the machine. As you can see, it's from 1990, so it's 24 years old. And I think it has been repainted 1 or 2 times. You can see the cable chain here. There's going this way and then into the center house of on the x-axis. I think it's a bit funny way they have mounted this system, this cable chain. I think I will move it a bit back maybe and have it going this way, and then getting down here, and instead of having this turn, then it's going into some box that's sitting here with the chain. The cable is just coming out of the underside here. So this is all the cables hanging down. The unconnected cables is the extra connections that's going up to to the X housing, and there's also some coolant. You can see there, coolant tubes going up. I'll show them in a moment. So in this end of the machine I will have a enclosure to store all the electronics. So there will be a plate going from this area there inside, and then this cabinet that's over here will be mounted in this area here and house all the electronics and all the low voltage electronics, and I may be using this old cabinet for the high voltage, the mains and so on, and relays for the mains and so on. So it will be two different cabinets. So this big one will have all the stepper motor drivers and interface cards, the bobs and so on. So that's what I'm working at the moment, to place this rails and have the plates to mount all the electronics and cases down there, and make this lower cabinet enclosure that's housing all the stuff. Also the cables that's going to each motor and to the center house up here, I will planning to replace them because the cables that is on the machine now is too short, and not all of them is shielded, so that's not very good. And there's constantly issues with the false triggers of the limit switches, so it's almost impossible to cut anything with the machine, because every time you start, then there's a false trigger on the limit switch, and then the program stops and ruin the material you're cutting in. So here's the enclosure for the current and electronics that's used on the machine that the previous owner has added to the machine. This display in the front is not used as any part of the machine. It's just that instead of removing it and having a hole in the front, he chose to leave it in, so it's not used for anything. It's some Willeman counter thing. I don't know what's used for. So here's the, you can see here there's the stuff and this unconnected. This Willeman. Sorry for the picture being basically upside down, because that's the cable output over there, and a DIN rail down there with the connection zone, and there's a relay I have added to turn the spindle on and off, but I hadn't got that to work yet because this Chinese controller can't pull the relay, so it has to be something in between. Here's the power supply. I think it's some sort of charger. It's 24 volts and 50 to 150 amp hours. That's the only label I can see. There's maybe some labels on the underside, on the sides of the cabinet, but it's impossible to see it at the moment. So here is a classic eBay Chinese controller. There's many of them on eBay. When searching on the internet, it seems there's a lot of people having issues with that controller. That it's when it's moving in 2 or 3 directions at the same time, it's losing steps in one of the directions, and that's exactly what I'm seeing. That when I'm moving the steppers all at once, then it seems to be losing steps on the x-axis. And I have this random trigger of the limit switches. It's not bad cabling, but I have seen cabling a lot better. The grounding wire that's coming in there is something I have added to try to fix the issue with the limit switches triggering, to see if there was some grounding issues or something. So that's the electronics, and there's the parallel cable going here to the PC, and the cables coming for the motors and limit switches is in this area. So it's a bit small, this cabinet, if you plan to have more stuff in the cabinet. So this will not be used. You see there's some of the cabling cut, and some of them have connectors, and all of them don't have connectors. This arm I have added to support the cable chain. You can see this. This is cut on this machine. It's aluminium, and then just connected to the back plate here. In this end you can see there's one of the feet and another of the feet, and in front there's the last feet. So it has 3 points, make it easier for leveling the machine. And I have added a bar to the car, and then it's having this one I have added, and then there's a holder for the feet. It's a bit hard to see in there, but there's this squared block, a round hole, and the feet is sitting in this hole to make sure it's not falling off the car when it's moving around and cutting. This plastic box is for the power connection. I'll show you that in a moment from the other side. This is one I have added on top of this housing. This is a 400 volt mains plug for equipment normally, and it's perfect outlet to have installed on top of this machine, because I can add the spindle I like and then have the cable going down. So this cable, a bit hard to see, but it's a fairly big cable that's going up at the chain and into the housing and coming up to this one to power the spindle. And this cable will of course come into this cabinet down here. Here you can see the enclosure that I'm planning to use and the size of the enclosure. So there's the old one, and this is the new one. The new one up here will be used for the low voltage electronics and interfaces and so on. And then the old enclosure will be used for the mains, relays and switches and so on. But this enclosure will be mounted in this area down here. You can see that I have added some holders in there. There's this rail, and over here there's the second rail in there, and that will hold that cabinet in this area here. So I can easily open this door this way out here and get into all the electronics. You can see the cabinet opened, and in the lower part of the cabinet there's a part that can be taken out. So in the low place down here, the cables will come in from where the computers are stored, and from the arms over there will go into the case and under and come out here, then will come into the case here. This is 21 centimeters. Times 60, and then 39 in height. I'm not sure where I have this enclosure from, but it seems to be perfect match to install in this area down here. You can see here this, and over here will be holding this enclosure in that area, and the size here fits with the depth of the cabinet. It will be, this is a bit deeper than the cabinet, so the cabinet will not be outside the frame in this area. Here you can see the center x-axis. This is the x, this is the z axis. It's a fairly big chunk of steel we have cut in one piece. See if we can focus here. So it's one piece. You can see it's going in here. This is one piece of steel that they have cut, and then there's two 16mm rails that's going through the block. As you can see, they are coming here, and then there's a small screw in here that's holding this bar from moving up and down, and there's You can't see it now, but in there's also a small screw. And then this block is moving up and down, and in here there's the spindle nut inside the block. Up here is the block that's holding the spindle from moving in that direction, and there's a bearing in that side. It's a bit bad design that this uses 20 millimeters of space in that area. It will have been nice if they could have moved that inside the block, but that's the way it is at the moment. So when I got the machine, there was installed some micro switches here and one up here, and then at one point this block has run into the switches and damaged them. So I'm installing this bracket, and we'll have some optical sensors sitting here and one here, and this small piece that's sticking out here will drive into the optical sensor, and it will know exactly where it is at the position, and it will be a repeatable location every time to 0.01 millimeter or something, or less, according to the spec sheet of the optical sensors. It's very good optical sensor. I will show you them in a moment. Here you can see there's the block here is mounted to this rail car, and on the back side there's a spindle in here. There's a spindle nut that's connected to this block, and then there's a motor inside the housing here, and a belt. So it's turning the spindle nut to move the x-axis, because the spindle itself is fixed to the machine and cannot turn. As you can see here, you can actually see on the grease that it's only going here to on the spindle, and it's fixed in this holder, and this is the limit switch, and that's the real. It seems that the spindle and the rails are very high quality, so they haven't been cheap, and I think it's original ones that's from the machine. This back housing of the X-axis car has some connectors and outlets for coolant, and I think coolant and some other stuff and air, and then there's some connectors that can be used for stuff, but I will maybe remove the connectors and replace them, because I don't have the plugs for this connector anymore. It wasn't supplied with the machine, so I don't know what connector type it is, and I'm not sure if I bother by trying 500 connectors and see if one of them will fit. I will maybe just remove the 3 connectors and add some new ones that I know the type of, and then have extra spare connectors, so I'll have them in stock if I need to change. The spindle is one I have added. The spindle that was coming with the machine was very cheap and bad one, so I removed that one and added this Kaiser spindle that I think is very good, and you can adjust the speed here, and you can actually disconnect the cable, so it's nice if you have to service it. The box up here is a normal 400 volt mains outlet, 3 phases, used for all 3 phases equipment in Denmark, and it's not using the round CE plug, the red ones. So this outlet socket was for me perfect to install on top of this cabinet, because it's a 5 wire 400 volt 16 amps outlet, so I can easily take this 240 volt spindle off the machine and add some bigger spindle, and then just use a connector and then plug it into this one, and then I have the cable going into it's actually the almost white one that's going down here, so it will go in there and have the relay in there to turn on the direction control and have the speed control and stuff like that. To the beginning I will just use this spindle and don't have integration with the spindle control and turn it on and off. I'm more concerned in getting the sensors working correctly and have the electronics working correctly, and then later on when I have the time I can maybe change the spindle to an sorry about that, to another one. So the motors that's on the machine is I have seen this design before, so I know it's a good brand design, but unfortunately there's no marking on the stepper motors. And this motor is exactly the same as the one on the back side. The motor that's inside here is another type. It's not the same type as the 2 other ones. So there's my cable mess at the moment. The machine was coming with this computer that is standing over here. It's a Linux machine that's using, it's very old, I think a Pentium 1, 2 or something, very slow machine. It has a Linux CNC on it. It was working fine, but I'm more into Mach 3, so I have to change the computer. So I had this spare old Dell computer that I'm using at the moment. It's a Pentium 4 dual core with I think 4 GB RAMs, and then there's a SSD 256 gigabytes SSD inside it. So I tried to use both a normal hard disk and a SSD and tested the timing in Mach 3, and it seems that the SSD was giving it a better timing inside the Mach driver testing program, and also the SSD is not sensitive if this machine will be moving around and there will be vibrations and so on from the machine going down to the computer. And the SSD is don't care about the vibrations and will work perfectly every time. So I decided to add a SSD disk. And also this car is on wheels, so using a traditional hard drive will maybe have issues with if the car was run into something in this workshop. Here's the backside of the machine with the connection going to the CNC machine. Over here you can see the original cable coming from the Chinese controller on this side, and it was plugged into the PC. I have then, trying to fix the missing steps and so on, added this extra cable and this extra small breakout board. That breakout board is a C26, I believe, from a company called CNC for PC in the US. What this board is doing is taking the output signals that's coming from the PC is normally 3.3 volts or something. That's very low signals and can't handle much current. So that's maybe the reason that when all axis was driving, then it loses steps. So what this board is doing is taking the weak signals, and here's a 5 volt cable going up to the USB port here. So it's taking the weak signals and converting them into strong 0 to 5 volt signals. There's a 20 milliamps current on each pin, I believe, and then going into the Chinese controller. It's called a buffer board because it's not doing anything except changing the volt level to be higher and stronger current, and it has helped a bit, but it hasn't fixed the issue for the missing steps. But it was a cheap board, I think something like $15 or something, from a shop in USA called CNC for PC. I believe the board's name is C26, and it's a buffer board. But it was worth trying to get this cheap board and see if it could help the Chinese controller, and it has helped a minor bit, but it hasn't fixed the issue. So I can't still cut anything usable with the machine without the limit switches triggering and losing steps and so on.